Hey, hi everyone. Get ready to electrify your understanding with Fleming's left hand rule. Today, in End of Ignorance, you will discover the magic of electricity and magnetism with a hands on experiment. So, why delay? Let's get started. To perform Fleming's left hand rule, I would like to demonstrate one small experiment, and for conducting that experiment, the materials required are copper wire, insulated copper wire, a cutter, magnets. I have taken neodymium magnets, battery. This is 9-volt battery, a tape, safety pins, one cylindrical shape object, and one plier to cut the wire. So the first step is to wind this coil around this cylindrical object like this. After that, one thing to keep in mind that these two ends should be open like this. After that, wind this two end in such a way that it will tie this circular part like this. You have to wind it again. Keep the two ends diametrically opposite to each other. Now the next step is to remove the insulation. There is insulation here, you have to remove it. And for that we will take the help of cutter and you will remove the insulation like this. While removing the insulation, you have to keep in your mind that you have to remove the insulation completely from one end and partially from the other end. Look at one end. I have removed the insulation completely, but at other end I will remove it partially. Okay. Now the next step is to attach the safety pins on both sides of the battery, here and here. So for that reason I have to take this step to attach the safety pins. You can attach this safety pin on other side of the battery, or else you can hold it like this. Like this. After that, insert the two ends of the coil. Insert these two ends of the coil through the holes of the pin. Like this. Now bring the magnet near to the coil. Give a gentle push like this, and you will observe that it starts rotating. Now friends, let's understand this experiment according to Fleming's left-hand rule. Fleming's left-hand rule is a way to understand the relationship between electric current, magnetic field, and force. To use this rule, let us arrange our left hand in such a way that our thumb, forefinger, and middle finger stay perpendicular to each other, as shown in the figure. According to the rule, the thumb points in the direction of the force, the forefinger points in the direction of magnetic field, and the middle finger points in the direction of electric current. You can analyze this Fleming left-hand rule by observing the video. Now let us check the connection. When the coil is connected to a battery, electricity flows through it, creating an electromagnet with its own north and south poles. Okay, now that electromagnets form and a permanent neodymium magnet that is placed near that and under the coil, it will either be repelled or attracted depending on the polarity of two magnets, which further cause the coil to rotate. You may recall that I intentionally left one side of the lead's insulation on the copper coil, isn't it? I left purposefully. Now this plays the role of switching the current on and off with each rotation. Friends, many modern devices have motors. So in this experiment, I thought it would be fun to create a simple motor using everyday materials. I have tried to demonstrate to you all the basic principle behind how a DC motor works and also helps you to understand the Fleming left-hand rule. It's a simple project that anyone can try at home. Have fun building your own motor. I hope you like this video, and if you do, then please share this video, subscribe to my channel, and don't forget to like and comment. Thank you and धन्यवाद.